We often think of AI as a tool, like a super smart calculator or a clever chatbot. But what if AI could become the scientist itself, asking its own questions, designing experiments, and discovering new knowledge? This isn't science fiction anymore. It's a rapidly emerging field called AI for research, and until now, we've been missing a map to navigate it. AI models, especially the huge ones known as large language models like those from OpenAI and DeepSeek, have become incredibly good at complex tasks like logical reasoning and coding. Naturally, researchers across all scientific fields have started using them to automate parts of their work. The problem is, these efforts have been happening in isolated pockets, a biologist using an AI here, a physicist there, without a unified understanding of what's working, what isn't, and where the whole field is heading. This paper addresses that gap by creating the first comprehensive survey of the field. The authors didn't just collect papers, they built a framework to make sense of everything. Their main contribution is a systematic classification of 5 key tasks where AI is helping science. Think of these as the core jobs of an AI scientist, sifting through existing literature to find new ideas, formulating hypotheses, designing experiments, executing those experiments, often by writing its own code, and analyzing the results. For example, in a task the authors call experimental coding, an AI could be challenged to discover a more efficient drug compound. It would reason about molecular structures, write code to simulate interactions, run virtual tests, and iterate on its own designs until it finds a promising candidate, all with minimal human supervision. By creating these categories, the researchers provide a common language and structure for everyone building these systems. Of course, the paper doesn't shy away from the big challenges. A huge one is rigor. How can we trust an experiment designed and run entirely by an AI? Ensuring the AI's work is reliable, reproducible, and not just finding strange statistical flukes is a major hurdle. The authors also point to the societal impact, urging the community to consider the ethical implications of automating scientific discovery. This work provides more than just a summary, it's a toolkit, compiling a wealth of applications, datasets, and software to help kickstart new projects. It forces us to ask a profound question. As these AI systems become more autonomous, what will it mean to be a human scientist in the 21st century? If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.